He gave you the quick overview there. We're going to be looking at financial data, though the difference between different types of data really comes down to what you're going to do with it and some of the use cases. But quick agenda. We have 30 minutes. We're going to keep to that timeline. I'll do an intro, overview, try to touch on the main streaming open source projects out there, Kafka, Flink, and NiFi. Go over a couple use cases, show as much demo as we can get done in this limited amount of time. I cover a lot of this material every week in my newsletter. Definitely check that out. I do a meetup. It's based in Princeton and New York and Philly, but I broadcast that everywhere, right into YouTube. And all the information, if you need to contact me later, is here, including articles. In December, I've been trying to put out an article every single day that's a business day I'm working. It's so far so good. We'll see if we make it until I stop working right before the holidays. So let's do an overview. We've got really fast data. Data's not so fast it arrives before I asked for it. That'd be kind of cool. But what happens is there's a lot of data. Now, for financial data, they have almost everybody's type of data, but they have some unique ones to them. Banking data tends to be something that hasn't changed in a while, except for the introduction of ATMs a long time ago. But ATM data, data from card transactions, data from banking transactions, data from branches, data from lots of different places. So a little more than some industries. And that includes edge data, whether you consider a branch an edge or a vehicle or things being transported. Data, there's trading data, there's regular enterprise data that everybody has. You know, you need to have, you know, everything to run your business and your people. So you've got all that data. Plus now there's tons of other data from logs, from chats, especially now that you're starting to build up textual data to use in various chats and other things you can come up with Gen AI. Now, be able to get this data as quick as possible, really important. It's not like the old days. If I spend an hour waiting for the data, that's a big deal. I mean, maybe there's some data you can wait on, but most I want to get that right away, get that into something like Apache NiFi, then start that processing, make sure everything is secure, governed, and managed, so I can get that into different machine learning and generative AI models so they could start looking for things going on. Really big one that we've seen that really requires a streaming platform is something like financial crime. You're getting different cybersecurity data, looking at fraud data, looking at surveilling different systems. There's a lot going on out there, and that data is moving quickly, and that data tends to be, you know, often changing, maybe from different systems. You don't know, do I have, you know, a fixed number of fields? Are they very sparse? Do they change? Is it sometimes JSON, sometimes Avro, sometimes XML, sometimes binary, sometimes a log, sometimes protobuf? That data can change. And fortunately, with the streaming tools, we can make sure we handle all of those dynamically, even when they change, get them into the places where they need to be processed and stored, and have decisions happen right away. And we could show you how you can make decisions with something simple like SQL. And regardless of where you're running this, again, parts of this could be in Kubernetes, parts of this could be on premise in various clouds, lots of data going on at once. But really, when you look at it, it's not as complex as you might think. So I'm going through some of these ones that just give you an overview really quickly. But the thing that comes up most often with things like fraud is speed. Like, as soon as that transaction happens, I want to be able to process that event at the same time. And we'll show you how you could do that with Flink SQL, so you could see what's going on. You also not just look at the one happening now. I may want to be able to look at other sources of data that we have stored in, a big data store or an open lake house to be able to make decisions. Also, a nice feature of Flink SQL is I could very easily do a window. So the window could say, I'm looking at this 15 minutes, 10 minutes, 5 minutes. We've seen this kind of changes to based on what kind of banking system it is, credit card. If, those two things happening in a very close period of time means something is more likely wrong. Do we call other systems to freeze transactions? Do we have ML models that we could do a real time fraud scoring against based on a number of attributes plus some things ML learned? And that could be flagged in the lake house so someone could give you a call and they'll have all the information they need, have that continuously update a live dashboard without ever things having to get into a final data store. I mean, eventually you will, because you need that to train the models, make them better, and to have all that information about, say, a customer for as much information as they have. If they've been a customer 20 years, we want this current information. Obviously, that's very hot right now, but lots of other uses for that same data. And maybe they'll want to add additional products to make things safer for them out there. Depends on what's going on there. And a typical application for me is NiFi will ingest the data, and that could be, say, change data capture from different data stores. It can be grabbing data from or sending data to different vector stores, getting data from edge agents, and those are NiFi, an open source agent that can run on, say, an ATM, say, a truck, say, a Raspberry Pi, NVIDIA Jetson, a laptop, wherever have you. That could be doing login analytics. It could be doing cybersecurity. It could be grabbing cameras. It could be running machine learning and deep learning and Gen AI models at the edge, and get that into NiFi. NiFi can distribute that with things like Kafka or Pulsar, make that available so Flink can do its real-time analytics, and that can be made into a materialized view that could be stored in a data store that could trigger alerts. Lots of different things you could do with those. We touched on Kafka. Obviously, there's other sessions on Kafka. You're not going to learn Kafka in 2 minutes. But for distributed apps, it is a great way for me to get those messages along the pipeline. And that is usually my pipeline. Have something like NiFi or some code, could be Spring Boot, could be a Flink app at the end. Get that data into Kafka. Now I've got it distributed, very reliable, decoupled. So whoever needs that can subscribe to it. That is a great way to federate that data out to as many people need it and get it moving as fast as possible. Scale as big as you need to. I have many customers who are running, millions of events a second through there, and it just keeps going up. So you could go fast, you get a lot of data in there, and it's separated by topics, which is pretty easy to understand. And I'll show you that in some real code quickly. Now, the most interesting part for me is being able to use Flink to do continuous SQL. So I start my query, it's running a cluster, and it's waiting for data. So an event comes, it processes it right away. You're not waiting. It is pretty nice to be able to get this data running, have it sync somewhere, have it display in a dashboard, go in a view, or just to make decisions. And with SQL Stream Builder, I'll show you that tool I'm using for that. Makes it easy to also bring in data from different sources besides just Kafka. Though Kafka and Pulsar are great, you also want to be able to connect to bigger data stores like Kudu and Hive and Iceberg, JDBC, different things. This will also let you get change data capture streams in from like Postgres and DB2 and Oracle and those places. The views are cool because once you've decided what that view is, you post that, make it available as a REST endpoint with JSON data. And I could use that in something like a Jupyter notebook, or I could use that in just some HTML dashboard. Lots of options there. Very easy to make these. based on your query. And people might know I'm a big fan of NiFi. NiFi's been around for a number of years, came out of the NSA for being able to work with any type of data. The newest version of NiFi is in process now, almost out, and it built a very powerful Python API and a new rules engine and support for Java 21, so performance is there, new kinds of threading, and the ability to have all these different Python processors to do different things, which makes a lot of sense now because there's very strong APIs for dealing with generative AI, things like LangChain, connecting to OpenAI, Pinecone, Milvus, ton of different things you could do there. One of the features why we like NiFi is provenance. So while we're quickly processing all this data, we get a lineage of everything that happened, full audit trail of everything. Great for debugging, great for troubleshooting, but also great for development, a lot of other purposes. I'm going to just show you some stock data coming through the system a couple different ways, and you'll get these slides, so you'll have links to everything going on. If you want to run these demos on your own, there is a Docker version with Flink and Kafka and everything you need to be able to run this really easily. I'm actually using this in this particular demo. It's that good. And you could do the same thing with NiFi, so you don't have to install these things. Makes it pretty easy. Let's get to the data. Like I said, we have it all in a couple of different GitHubs to make it easy. So the first demo, this one is a little silly, but I like it. It's in a Slack group. Now, I've used this demo to be able to communicate from Slack to NiFi to LLM and get the results back. But for things like stock, doesn't make sense for me to have the stock going right now. So like, let me do NVIDIA. Doesn't make sense for a language model to do that. So I'm just going to have NiFi call that API to get the results back. Tells me the current stock price. That one, what happens is when Slack posts messages, NiFi acts as a universal endpoint for that as an HTML receiver, gets that data in, I parse it out, get it in a nice format, and then I decide here, is that something that looks like it has stocks? And I put the word stock in there to make it easy. And then I have an NLP processor I wrote with OpenNLP, takes the input in there and grabs a company stock name. And here I run a query to get back the stock symbol from that company name. And then I grab just the fields we care about, company name and symbol. And then I make another call to 12 data with that stock symbol. I get the stock symbol, clean it up, put it in a nice format, make it a full record that I want. And I can put it in a database if I need to. And then here, posting that to Slack with the company name and some of the stock data. Pretty easy. I could use that same data to push that into to whatever, but as you see here, I just returned it here just to give you one idea of a flow that you could do with real-time data, interactive data from people, data from third-party REST elements. Combine that. If I didn't want to do that, when this is done, I could send this to go to an LLM model, get the results from that. So, your pipelines can be dynamic based on what's going on. If I need to ingest data, I can, here I have this just running on demand. A nice feature of NiFi is things can run on a schedule. They can run continuously, or you can run them on demand. And then it'll run through the system, convert data into formats I like, update and add fields on the fly, reformat dates, push them into Kafka. Once it's into Kafka, it's very easy for me to get the data available here. And then if it's in here, I can query it. So my query here is doing max, min, and average for these three stocks that I'm looking at. High, low, close, and number of rows for each one, just to give you an idea. So I could do that powerful query, and that's running continuously. And if I look here, I could see that running over here and see what it's doing with the group by an average. See how many records are popping through there, 50,000. And that's just running on my cluster. If I needed to scale out more, I could add more nodes to my cluster and have it go as big as I need to. Now over here, I have another query going. This one is really simple. This is just reading from Kafka. But what it's doing is it is receiving Kafka messages and just do them as soon as they come in. I've got a old-fashioned application run over here that's receiving WebSockets with Python and then just pushing those records as they come in into Kafka. And then from Kafka, as soon as that message arrives, as you can see, a new value comes in. I get that new value. Here it's looking at volume and prices and different trade conditions and times. The data difference isn't a big deal. I could take any type of data. Is it text data? Is it money? Is it math? Doesn't really make much of a difference. We've got all the ability you need there without too much of an issue. But to give you an idea of different things you could do, I can create a materialized view with a minimum number of rows, its unique ID. And then here I could just, looking at that data comes back, I can decide if I want to show all the data, if I want to add a filter again, and then I could push that data to whoever's looking for a REST endpoint so they don't have to know about Kafka. There is also a ton of other types of data I could pull out. If you look at the different virtual tables I have here, I've got this one is just grabbing from Postgres. And this is Postgres on table changes for CDC. And I've got one here. This is just a regular JDBC connection to a Postgres database. And that one I could change on the fly. Tons of different data sources, whether this one is an upsert, so I could insert into this Kafka topic with whoever calls this one. And the SQL is as simple as could be. Like if I wanted to insert into another topic, maybe the results, that would make more sense with this one here with this min and max. I could just add an insert into, whatever upsert table that I created for this, and it would just stream that data in there as it happens. So whenever this updated, very easy way to distribute your data and do it in the simplest way, whether the data is going out to a data store or going into another Kafka topic. Very easy to do this. And it's makes a pretty easy way to write applications. As you saw, I'm just writing SQL. I don't have to worry about how it's being deployed. If you want to make it, more iron strong, you could wrap this in your own application and deploy that, whether that's Java, Scala, or Python. Though not too many people doing Scala now. This is just another one where I'm grabbing all the FinHub stocks. I've got, again, very easy to read from Kafka with NiFi. And for it to decide on what the data is on the fly and change it, here I just split it out into individual records. Really easy to do this type of processing and go from there. I have a couple of pieces of content linked at the end if people have any further questions they have. Otherwise, I'll go and stay in doing some more exploring in the demo until we get to the point that we're closer to the end here and we have time for some questions. But if you have any questions, definitely drop them in there and we will get to them depending on what you're interested in and how much time we have left. So far, we're doing pretty good here. So not a big deal here. And we'll go back to sharing the demo, and we'll go into some of the features here. I glossed through really quickly just to make sure we got through the demo. One of the nice features of NiFi is I can call any REST endpoint, whether it's a get, a post, delete, whatever you have. SSL context, set your user agent, being able to cache things, how you want to do cookies. And if you need to send any things like a key to be able to log into certain ones, we could just add extra keys here, and they could be sensitive, so you don't have to worry about your parameters. Pretty easy for us to be able to do that. If something is going wrong, we can monitor everything from the UI. What's unique about NiFi is whatever you see in the UI has a REST endpoint behind it, as well as an SDK. So if you need to programmatically look at things, you could do this by looking at a REST endpoint, or you could look at it with the SDK pretty easily if you want to do that. So right here, I have this paused, and I'm not losing data. It's just piling up in a configurable queue here. And this would let us get to, if we needed to do back pressure, we'd have that there. And I could let that go. Right here is a unique processor that lets me slow things down. If I want to do a demo and get 1 record a second, I could slow down my data so it's not so fast. Again, kind of silly in most use cases, but helpful if I've got trying to show you things in a demo. And I could just delete things. Very easy to start, stop, change things on the fly. Like if I decided I didn't want it to go to this next source, I could just pick something else. I could just pick something I want to send it to. Maybe I want to send it to Cassandra or to generic database. I could just pull it here, change that live on the fly. Pick if it's JSON, pick what type of database it is. It could be generic as well, just a regular JDBC. I could have this determined on the fly, or I could say it's always an insert. Like here, I could just send it to DB2. And if I knew what my schema was, I could hook it up to a public schema, and then whatever that table is. And then it would just start inserting it for me. And if there's errors, I can handle errors here, depending on what you want to do. I could have it retry a couple of times in case it fails. Lots of options there. And another thing that people are interested in is I can control how to get information out of NiFi. Like you may want to be able to write a SQL query against different events coming through the system, and then maybe send them to Kafka. So what I could do here is if we look at the documentation, I can look at all the internal data in NiFi as a table and then run SQL queries against them, including things like joins and aggregates, just like you'd see in regular SQL. So it makes it easy for you to look at things like, well, am I running out of Java JVM storage? Do I need more RAM? What's going on in the last 10 records? You could find errors that way. And then you could just push them, like here, I could just push them into Prometheus, push them into Azure or Datadog. Pretty easy to be able to do that programmatically based on what's going on in the system. Now, each of these systems here are separate, what we call a process group that we can put into version control. We can give its own parameters. Could do a lot of different things very easily. Have its own controllers related to it, and those controllers do things like JDBC connection pooling to schema registries, SSL, all those kind of fun things you might be doing here. And let's go to another one real quick. We on this one. Make sure we're on the right server. There's a lot of different things, from working with local cameras. and then sending binary data into a Slack group based on the APIs there. So I just grabbed a picture. I don't know if there was an issue because I'm using the camera for another thing here. So I just uploaded a picture. If we go into here, do we see it? Let's see. All the metadata I could send to Slack. Very easy to send data to Slack. Yep, there's me. Again, no virtual background on that one. So it doesn't matter if you're dealing with images, you're dealing with uh, data. All of it can be done in the same place, whether it's calling generative AI, whether it's calling weather data. Very easy to do. All data, high speed. We get that cleaned up. We get it validated. We get it into a Kafka topic. Then I can query it at scale very easily. And like for this one, I can continuously send data and it just keeps processing on it. I can see we've got this in sampling mode. So we're not showing you every record. I'm sending hundreds of records. It's looking at one a second. Otherwise, things get really busy on the UI, but you can have it still processing that query. So if I had inserts on, it would be inserting all of them, not just the samples that we show.